Hello, and welcome back to the Game Dev Log. So, this is the number 11, starting out on Monday. I was messing around thinking, what should I do next here? I was looking at the one of my shaders, and it demonstrated the ability to kind of mask off different different meshes by moving a plane around, and I thought I could adapt it and use it to make my stealth shader work the way I wanted to do from top to bottom. But it's kind of a bit of work, and it's kind of a low value win. So eventually, maybe I take another crack at it. That's categorized as a final production polish. So I kind of went back to working on the AI FSM finite state machine this week. Working more on the um, the finite state machine. As you can see, there's a bunch more states, and it's getting a little complex, but actually works pretty good now. Um, so I left off on Monday working on the searching state. Um, Moreover, working on the chasing state. It's so pretty much how to do shooting when the AI is chasing the character. I wanted him to do some shooting while he's chasing, so I implemented that, and also his accuracy is different when he's chasing him around, so that works. Also, there was issues on different things like when the target is lost, like opening and closing the laser field to indicate that the target is no longer acquired visually. Working on things like once the target is lost, transition to another state, transition to move to the last known location, fixing issues like when like a bug, the target could actually be acquired through like a wall, which is not right. Doing a lot of testing and fixing random bugs as they appear. Um, let's see what else. Go back here. Um, so adding functionality to go to the last known location. So lost target, it's going to go to the last known location. So just a lot of implementation. It's going to go to the last known location. And when it gets to the last known location, it will do a look around. So I'll demonstrate all these things in their entirety when I'm finished discussing here. On Tuesday, I was trying to get some work done, but there was a lot of distractions because of the election buzz on the interwebs. I was working through the day, but I kind of got pulled away at the night when the actual election was happening. But I did get some work done. I implemented let's actually do a little demo right here. If you can see, when he loses the target, there is actually a hologram right here of the last known, and it fades away when he reaches the target. So I have implemented a shader effect, so that basically copies the mesh correctly and puts it at the position, an instance, and then fades away and destroys when he gets there. So you're kind of seeing. So that was an interesting bug I saw there. The target moved through the ground. That's not right. all in all. And then again, another bug that you can see, he actually, sometimes he doesn't get restricted to the mesh, he actually falls off the world. Most of the time, 90% of the time, that mesh target is placed on, it doesn't go past. But this time he actually went off. So that's another bug. So it's still, today at the end of the week, there's still bugs to be addressed. I'm making a list. But anyways, yeah, just fixing bugs. Throughout this whole week, working on the FSM mainly, there's just, I would build new functionality and then it would break previous functionality to add more bugs. So it was a constant grind of adding new stuff, going back and fixing things that it broke, regression. It was a pure grind. So much testing because this FSM grows more and more complicated, and the AI, the rotation, the head tracking controller, more complicated. So just implementing more functionality and then just doing a ton of testing to track down bugs and refine it. So Tuesday, got the fade marker when the target reached, and more work on the FSM search state. So Wednesday, I was completely distracted by the fallout of the election, pretty much glued to the interwebs, and I had to take the dog to a vet, but I still got some work done that day. Like I was saying, the state machine is growing more complex, and how it behaves in the full cycle. And I was pretty much, back in like enterprise scale complexity, how to manage a very complex system, and just keep working through. The only way to do it is to keep working through it, spotting issues, keep working on, fixing bugs, keep grinding, lots and lots of testing, and just kind of polishing, like doing QA work to polish to a certain quality scale. It's never going to be, as I know in software, it's never going to be perfect, but you want to get it to a certain level where it just doesn't work on the happy path, but you're testing this scenario, that what happens if I do this, what happens if I do that, and trying to break it. You want it to be very, it's like tempering steel. You want to bash the crap out of it with a hammer. You want it to be very strong, very flexible. It doesn't mean you can never break it. It just means that it's very durable, quality software product, and that's what I'm used to. That's what I'm trained to do. That's my skill and expertise. Like, I'm a systems engineer. That's why, I can work on this complex stuff. Most developers, they're making India games. They're strong in art, they're strong in other things, but they're not strong in engineering. And that's one of the, it's like I can do engineering, but I'm weak in the other things, like asset creation. That's why I purchased a lot of assets just to use so I can implement the system. And that's where my skills really shine here. It's like really starting to a complex system that's growing. Like, how do you implement properly? So a lot of different cases, fixing like what happens when the target is lost in transition from state to state, and just testing the interactions and the transitions from state to state to make sure everything's working properly. All these, there's like 1,000 little edge cases, it's like, and you gotta be careful. If you change one thing, you don't break another thing. And it's like you add something and then you have to regression test. So at the end of the day, I got to the point where I felt, it was good enough. I wanted to. After he lost the target and reached the last known position, he would transition to the searching state. But choosing a random direction, that's fine. But I wanted like a 50-50 chance that when he chooses a direction, he can choose a random direction, or a 50%, or some random number, he could choose the actual direction the player is in. But the problem was, going into Thursday, I realized my understanding of vectors and what exactly they were was not quite sufficient. My training and education of 8 months, I understand, okay, vector, I believe them to be simply a point in space, but that's not exactly true. A vector describes actually two positions in space. My confusion came from, working with the Unity, like, oh, here's the position vector, okay, it's just a point in space. But what it's not telling you is that it's a position vector. So a vector essentially is 2 points, and this position here is describing if you think about an arrow of a direction. So a vector is essentially a direction. And you think about the arrow, the head of the arrow, the tip is this point in space it's describing, right? Position, X, Y, and Z. So what's the tail of the arrow? Where is that? Well, that's emitted. In a world transform vector, that's always the world center. That's 0, 0, 0, which is somewhere around here. So it's always calculating from the world center. And my problem was I wanted to take the center point of this target, which is not the world center. I wanted to create an object here and add a certain distance, another vector out here, right directly in front. So I was struggling, like, how do you, is it local space? Is it world space? Like, what is it? How do you do it? So I was really struggling with that until I sat down and really understand the concepts once again and solidified my understanding of, what a vector is, how it works, how can you use vector math properly, not just in relation to the world space, but the local space of a, game object. How do you find the distance, like these vector math problems, how do you find the, how do you add a vector from not the center of the world, but from this other position properly. And then also, I've done the rotation, like one vector rotation around another. So I applied that in order to get the angle direction. So I was thinking it gives information about the angle and actually Euler angle degrees, but it actually, sitting down and learning again, it's like it gives you a position like a float of an actual direction, a vector angle direction, which is essentially a direction as well. So all said and done, I was actually able to solve this problem with a custom implementation, custom code. Now I have a more solid understanding of how to do things like this in the future, and pretty much solve the problem of, okay, move towards wherever instead of moving to a random 360 angle, move towards the actual player. So I got that working. And then coming down to Friday, working more on the finite state machine, I was struggling because I had to detect when the AI was actually, it gets a point on the nav mesh, but how do you detect when it reaches that point? There was no, so I was digging into the vector system, and I was like, okay, what is this point here? What is that in vector? This is actually a nav mesh point. So the vector system is taking the point that you give it, and the nav mesh is interpreting where it can actually travel to on the nav mesh. And this is 90% reliable. So I had to figure out, okay, because it's constantly updating this point, but it's like, I was running into race conditions. It's like when, by the time I switch states, it was like a race condition. I switched the state, but how do you coordinate when, like, the point when you switch the state and it updates its position to the right target? Like, I could switch the state, but the current target could be here, and then it says, oh, I've already reached the point too early. So finding a reliable mechanism for, transitioning between two states, the actual, look around to searching and the searching to patrol was actually some tricky business. I found one reliable way of transitioning to look around, but there was a different reliable way from transitioning back, from searching back to patrol. So do a lot of testing, do a lot of researching. I finally got it into a solid, like, once again, like, that's the thing about engineering, like, if you don't have a perfect solution, like, it's never going to be perfect until you can find a better solution, but you have to have it tested so it's, you know, test the crap out of it so it's like super reliable. Like, doesn't mean it's never going to fail. It just means that, you can't get it to fail, so it passes the test. So you got to bring it up to a certain quality point, and then later on you bring in like people who just dedicated to testing and really try to break it. But another problem I was facing that I didn't realize I was getting myself into was implementing different coroutines for the head tracking. In certain situations, I wanted to bring the head back into alignment, or in a certain state I wanted to randomly patrol rotate, or different. The problem, the way I implemented the head tracking is that like different parts of the code can call these portions and set it off asynchronously. So what was happening is like you're getting odd behavior where the two different coroutines are fighting for control over the head rotation behavior, and you could see it kind of fighting against this stuff. So the way I implemented it, I didn't implement it in a way where it's safe to execute only one, type of rotation at a time. So it allows for these bugs to occur. So and it's starting to get that head tracking code is starting to become a spaghetti mess, uncontrollable. So it's kind of ripe for refactoring. For now, I actually got in there and put patches in there to make it work without too many bugs. But the fact that it can happen is proof that it needs refactoring in a way that you can eliminate any sort of possibility from that happening. So that's probably something to do later before that controller gets any more complicated. But at the end of the week, I got it into a state, not with a few bugs outstanding, to where it's reasonably solid and it passes most of the testing. There's still some issues like you've seen before in the video where it misbehaves, but I'll demonstrate now the actual functionality. Okay, so he's seen the target, he spotted, he goes to the last known location, he looks around. Okay, now he's going to, after he's done looking around, he's going to pick either a random direction or my direction, which he chose my direction. It's at the random chance low. Selects a new target and patrols to that target, doing his random look around while he's doing that. And then when he reaches that target, it gets detected, and now he's going to do one more look around. And if he doesn't find you after that, he is going to go back to the patrol state. So it's a full state cycle, not just working on a simple happy path, but like he's going to pick the closest location. This system is sort of hit or miss. It was working sort of, but that still needs more work. Letting the system decide the nearest location to go to, the nearest waypoint. But doing a lot of testing of all these different edge cases, like, what happens if he sees you a little bit but doesn't spot you? Okay, goes right back to patrol. That's working right. What happens if he sees you, spots you, starts to chase you, but then loses you? So all these different combinations, whereas before is like, okay, he's in the looking state, but he sees you, but he doesn't spot you. In that case, it was broken where he would actually go back to the patrol state. But fixing it, he actually stays in his current state. So implementing logic to say, if he spots you a little bit but doesn't fully spot you, he's not going to go back to the patrol state. He's going to go to the state that he last was at, which was the looking around state, which is what I want. Previously, I could get him to go back to always go back to the patrol state by having him spot me in just a little bit, but not spotting fully. So yeah, like a lot of testing work. When the system gets mighty complex, you have to test all these little edge case scenarios, and it's just a lot. I can imagine, AI controllers that are a lot more complex. You really have to put a lot of work into managing all the transitions and all the edge cases, and just do a ton of testing to make sure everything uh, works as it should. But at the end of the day, you have a more dynamic, robust um, AI controller that does a lot more things. It's a lot more interesting, and it behaves a lot more the way, you know, you know, yeah. It's not just a basic controller that like it was that, spot you then go back to patrol. Not very interesting. This is actually a full AI controller cycle that I can actually build and append onto, but it circles all the way back to itself, from entry, and knows how to get into spotting from different states that I can build on top of. And that's, it incorporates, different things, not just spotting and chase back to patrol, but more dynamic, from the combat state to losing the target to initially looking around all the way back to patrol. So this is what I was looking for. I could still add more things, but it's kind of at the level that I would expect a nice AI and a nice game to function at a basic level. I could add more stuff, more custom stuff, but this is like the minimum of how an AI searching in a stealth game should be expected to operate. So there's more work, I think, but it's actually, more work, more bug fixing, more polish for sure on the AI controller. But the feature set, I think, of this AI is actually coming down to the final innings. So we'll put more work on it to get it really in solid shape. Maybe do a little bit of refactoring on the head tracking controller next week. But it's actually looking pretty good. So even though a distracted week, I actually got some good stuff done filling out this and completing this AI controller more. Okay, so stay tuned for more next week, and we'll talk to you later. Thanks, bye.